Hello everyone, my name is Zara from the Johanna Foundation. Today I'm going to present our collaboration research between the Johanna Foundation and Blue Forest Foundation, which titled Empowering Fish Farmer Through Coastal Field School Towards Sustainable Aquaculture Practice. But before I go further, I'd like to start this presentation with an intriguing question about where does most our seafood come from? Some people would guess it's from the sea where gazillions of sea creatures live there, but some would say it's from the fish pond that have way smaller areas than sea. Now let's check the fact. Based on the data here, we can see the captured fish production has been stagnant since long time ago due to overfishing. Vessels and all the fishing technologies are getting advanced, resulting not much fish left on the sea. On the other hand, aquaculture production has been skyrocketing. It even reached nearly 115 million tons in 2018. So I think it is safe to say that the future of seafood production lies on aquaculture production. And the good news is our country happens to be one of the leading seafood producers in the world. In terms of domestic production, Central Java is among the major seafood producers in Indonesia. But its hefty contribution also comes with a challenge. Abrasion and robbed flood have adversely affected the farmers' ponds, just like what happens in Demak. Demak coastal areas consists of mangrove swamp forests that provides enormous ecosystem service for food production. To address adverse things like coastal degradation and irresponsible aquaculture practice, an initiative called Coastal Field School or CFS has been implemented as part of Building with Nature project. CFS is basically implemented in multiple villages in Demak, but this study only highlights the one in Bedono village. We focus on the CFS activities that were taken from March 2019 until September 2020. This area is known for its brackish aquaculture commodities such as milkfish, tiger pound, blue swimming crabs, and blue cockle. 1/4 of the household in the village is highly dependent on aquaculture for livelihood. However, the pond's embankment conditions have been severely damaged due to land subsidence, flood, and decreasing water quality. Despite the situation, the farmers were still seeking for solutions to make their ponds productive again. To empower the farmers, an initiative called CFS was implemented during 2015 to 2020. In principle, CFS is adopted from an earlier approach called Farmer Field School. It supports the farmers through a series of meetings where the farmers can gather and discuss their own ideas to solve the problem they face using local resources. To identify the CFS contribution to farmers' empowerment, this research compared the before and after CFS took place. The measurement was conducted from June to September 2020. We did pre and post tests to measure the participants' knowledge improvement. We analyzed tests using statistical approach called Shapiro-Wilk and paired t-tests. There's also an experiment that compared the business as usual plot and treatment plot using laser approach to identify which of them is better, and whether the result of the study could lead to economic profitability. Speaking about the test itself, the 10 questions range from ecosystem function, the role of crab and blue oyster for ecosystem, and environmental factors that hamper productivity. Among 26 participants, only 10 managed to consistently attend the whole meeting and took pre-test and post-test. And these 10 participants scored the highest. The rest farmers find it difficult to consistently attend the meeting due to working, family gathering, or village event. The program employed laser approach that emphasized two things. The first is local resource optimization, and second, minimizing the use of external input. In this program, the farmers use local substances such as microorganisms, rotten fruits, and saponin. They were processed to they were processed to be main ingredients for the fertilizer. CF has also equipped them with technical skills such as how to measure pond water transparency and water salinity. This is the comparison of control plot and treatment plot of blood oyster cultivation. We can see there's a growing number of the average weight after harvest that up to 65%. This growth also translated into economic profitability, where we can see the net profit has risen by nearly 30%. The study sampled the farming results of 6 CFS participants, where each of them has half hectares to almost 3 hectares of ponds, and the profit per hectare was ranging from 300,000 to 58 million rupiah. These different results is affected by various circumstances, because there's also some obstacles like external factors like aquaculture theft and road flood. The ponds are located at the shorelines that far from the farmers' houses, so it's pretty hard for the farmers to secure their ponds, resulting their cultivated species easily stolen. And thus, for milkfish, road flood has worsened the pond condition since mangrove areas are degraded. But those who grow blood oysters had a better experience because it's not easily carried away by the flood current. Based on the explanation earlier, there are several things we can conclude from this study. First, sustainable management of coastal areas is the key to protect aquaculture practice in Demak and anywhere else. Secondly, CFS along with LASA strengthen farmers' resilience by facilitating them to transform abandoned ponds into productive ones. And third, scaling up this effort, especially the ones in suboptimal land, can be part of promoting action to sustainably manage food and livelihood resources. Thank you.